Okay, so we're going to do monomials and polynomial notes. For the most part, guys, it's stuff you already know. So I'm just basically just refreshing your memory on the polynomial rules. Okay, that's basically what we're doing today. Just to start, I want to remind you what a degree of a polynomial. I'm sorry, degree of a monomial. I'll start there. And it's the sum of the exponents of its variables. So if I give you a monomial, and you tell me what its degree is. Here are the three monomials I want to talk about. You see if you can give me the degree. Remember, it's the sum of the exponents of the variables. So does 3 have any variables? Nope. So the degree is 0. Excellent. Here, the x has a 2 and the y actually has a 1 there. That's not written, correct? So the degree is 3. And on this one, okay, 3 plus 2 is 5 and the a actually has a 1. So the answer is 6. There you go. Good job. Now we're going to talk about all the different exponent properties. And guys, here's the issue with them. I'm going to try to start, but they're kind of all mixed in together. So sometimes we'll have to refer to one in order to use the other. Okay? But we'll start and see what we can do with that. Exponent properties. If I told you a to the m times a to the n, when you multiply and the bases are the same, you actually are adding the exponents, right? That's what that property states. So in other words, like just an example would be x cubed times x to the 4th is actually x to the what? X to the 7th, remember? Okay. Guys, when the bases are the same, you add the exponents. You multiply. What if I give you 5x squared times 2x? 5x squared times 2x. 10x to the 3rd. All right, so there's just a little bit of stuff you've done in the past. Number 2. A divided by b to the n power. Okay. That's the same thing as it applies to both a to the m and b to the n. Here's an example. X squared over y cubed squared. Remember, it goes to both here and here. So you get x to the 4th and y to the Okay, so our next property is a to the negative n power is the same thing as 1 over a to the n. Understanding that, then what would x to the negative 3 power be? What is that negative exponent actually telling us to do? Where's it saying it goes? In the bottom, the denominator. Now, if that's confusing to you, let me talk to you. Here's a little think bubble for a second. Let's address that. Okay, if I told you a cubed over a to the 5th, remember the property, and like I said, they're kind of intermingled, but remember the division property. What do you do with the 3 and the 5? Do you remember? You subtract them, right? So 3 minus 5 is actually a negative 2, isn't it? Okay, so what you have here is a to the negative 2. 3 minus 5 is a to the negative 2. Well, if you look at the picture of this, 3 on top and 5 on bottom, where are they left over? On the bottom. So this is the same as 1 over a squared. So when you subtract 3 minus 5, you got negative 2, right? So the negative 2 is actually telling us, a way to tell us that, guys, when I subtracted, I had leftovers in the denominator. And that's why they're written like that. And that's the reason. Okay, it's the property of subtraction. I'm sorry, the property of division. Okay? So on the other side of that, what if I gave you 1 over x to the negative 3? What if I put your negative in the denominator? What do you think is going to happen? Yep, it's going to go to the top. So it's actually x to the negative 3. It pushes the top. Now, what's confusing to some people about this is that the negative 3 right here does not mean that the fraction is negative. All the negative exponent is doing is telling you where the x belongs. Okay? So because I got a negative right here, it meant that it belonged in the bottom. Alright? This one. Let's look at them individually. So I want applies to the numerator and it applies to the denominator. Agreed? Okay. What does this negative 2 tell me I should do with that 3? Where does it belong? Right, it goes to the bottom. So I have actually a negative 3 squared in the denominator. What does this negative 2 tell me that the 4 belongs? Right, the 4 belongs in the top. So what I really have then is 4 squared is 16. What's a negative 3 squared? 9. Good. So there's your answer. Does that make sense? Any questions on how I got that answer? Okay. Let's go to D. 5 to the negative 2, x to the negative 4, over y to the negative 2. Give it a shot. This 5 belongs in the denominator, so we have 5 squared in the denominator. X negative 4 would go to the denominator. The negative tells me where to put it. And once you put it where it belongs, the negative goes away. Okay? This y negative 2 tells me that they belong in the numerator. So when you clean it up a little, you'll just have y squared over 25x to the 4. Move to E. A a to the fourth, b to the negative fifth. Okay, for this one, a to the fourth is going to stay in the top numerator. The negative tells me the b is going in the denominator. Got it? Another property. A to the m raised to the n power. Does anybody remember what to do when you raise a power? What am I going to do with the m and the n? Good, I'm going to multiply. Okay, I'm going to multiply. So that becomes a to the n times n. Hang on, let me show you something. I want to clarify. Watch. That means if I have a squared times a cubed, I have x to the, I said a, I'm sorry. If I have x squared times x cubed, I have x to the fifth. If I have x squared raised to the third power, I have x to the sixth. Do you see the difference between the two? Same bases, you add. Raised to the power, you multiply. Okay, they're the same properties, it's just been a while. That's what number 4 is telling me. Here's an example. X cubed raised to the fourth power would be what? X to the 12. 4 times 3 is 12. Another property. AB raised to the n power. That's just telling me you want to take the m and apply it to both. So that's a to the n power times b to the n power. So A is pretty easy. B, you might want to put a star by it. For A, you just apply the 2 to both, so you end up with x squared, y squared, right? But for B, when you apply the 3, don't forget about the 3 that's already there. So what you actually have is, what's 3 to the third power? 27. Now what's x cubed raised to the third power? 9. Excellent. And then y cubed. Our last property. A to the n over a to the n. We've already talked about this a tiny bit. What does that mean? What do I want to do with m and n in this case? It is division. Right, excellent. So you subtract them. I agree, right? She gets sticker for that one. Please help. Maybe you tell your answer. Alright, here you go. X to the 8th over x to the 5th. What am I going to do with the 8 and the 5? I'm going to subtract. Okay, I've got 8 x's in the top, 5 in the bottom. They're all going to cancel, leaving me 3 on top. Because 8 minus 5 is 3. When they're real easy like that, it's not a big deal. You don't even really think about that you're subtracting because it makes sense. But you need to understand you are subtracting because they're going to get harder. So here's another one. A b to the 7th over a cubed b to the 4th. Once again, okay, you already can kind of look at it and know the answer. But again, you need to realize you're actually subtracting because watch what happens. Okay, I'm actually going to do 1 minus 3, which is negative 2, correct? So it means I've got 2 a's in the denominator, which you probably already knew that. Okay, but again, we're going to need this property, so just give me some time here. This is 7 minus 4, which is 3, which is positive 3, which means your b's are left in the numerator. Most of you can just look at that and get it, right? It's when you get to this type of problem that it gets a little more hairy. Okay. This is what I meant by telling you to use the property. 2 minus negative 2 is actually how much? 2 minus a negative 2 is minus the negative. So you get 4. So there are 4 a's in the numerator. Then on b, negative 2 minus 3 is negative 5. So I have 5 b's in the denominator. That's why that I kept telling you have to be careful with it. Now, guys, let me show you some common sense here. This one's pretty easy, but if you think about it, these a's are negative, so they belong up here. So I've got 4 a's in the numerator. Do you see it? Whereas here, these b's are negative, so they belong down here. So I've got 5 b's in the denominator. Right? Okay, that's what's going on. The problem is when it gets really big and messy, that gets pretty hairy moving everything around. So what you end up just doing is just apply the property and trust it, right? So I look at these and I say, all right, 2 minus negative 2. That's 4. So it's a positive 4, so I know there's 4 on the top. And then you say, all right, here, negative 2 minus 3 is negative 5, so I know the 5 belong in the bottom. You just trust the rule. Sometimes it gets cleaner. It's cleaner and easier. Okay, but that's what it's doing. All right, now go to the next one. A to the negative 2b cubed over a to the negative 1b squared. Negative 2 minus negative 1 means I have an A where? In the bottom. And then 3 minus 2 is B in the top. Okay? All right, so those are all your properties. Same properties you've always had. We talked about monomials. How many terms are in a monomial? How many terms? Think about the word mono. One, right? So and then now we're going to talk about polynomials. How many terms do you think are in a polynomial? Yeah, more than one. Many, right? Poly, many. So we have polynomials. And it's the sum of one or more terms. So here's a polynomial. How many terms do you think it has? It's a pretty easy question. How many terms are there? 2. 1, 2. 2 terms. It's called a two-term. And 2 terms are used called binomials. More specifically, it's a binomial. What about 4x squared plus x minus 8? How many terms are there now? 3. So we're going to call that a trinomial. It has 3 terms. It's called a trinomial. It's stuff that you kind of know. It's just been a while since you talked about it. Okay, in the notes, in the very, very beginning, we talked about, here was a monomial, right? And the degree of a monomial. When you put a bunch of monomials together and create a polynomial, you also combine the degree. This is how you do it. It's the degree of a monomial with the greatest degree. The word degree is like 5,000 times in that sentence, but that's what it means. Two x cubed y to the 5th z plus 3x to the 4th y cubed. This is a polynomial. How many terms are in it? 1, 2. 2 terms. Agree? So now I'm going to ask you next, what's the degree of this? What's the degree of this one? 5 plus 3 is 8, 9. Right, so the degree here is 9. What's my degree here? 7. So what's the degree of the polynomial? Read the definition. Is it 9 or 16?
I think it's 9.
Good. It says the degree of the monomial with the greatest degree. Did it say anything about adding them up? Nope. Okay? So what you do is you find the degree of every single term, and whichever one has the highest, that's the degree of the whole entire polynomial. So the answer is 9. Try another one. The degree of the 3 is nothing. What's my degree here? 3, 1, and 1 make 5. 2, 4, 5, 6, 7. Don't forget that even though there's not a number, what's actually there? A 1. So what's the degree of this polynomial? 7. Okay. You don't add them up. Okay. You think you got all the properties and degrees and understand that okay? Then let's move on. I'm going to do some simplifying. (8r squared plus 5r minus 6 minus 6r plus 7r squared plus 8. trip you is the negative. So you have to be careful. And when you're adding and subtracting, you add like terms, right? Subtract like terms. Be careful of the subtraction. You have two options. You can just be cognizant of it and be careful, or you can go ahead and take care of it and get rid of it. You change this to plus and go ahead and distribute. You can decide either way. Right now, you're only allowed to put like terms together, which means if you put the 8r squared with the negative 7r squared, you would have how many? 1. Good. And if we take the 5r and the negative 6r, we end up with negative r. Why did I start with the r squared? I'm not done, but why did I start with the r squared? Yeah. It's customary to start with the highest power. Okay? If you see a textbook written answer or in any math class written answer, they're going to start in, they call it descending powers. Highest power down. Okay? It's just the way that it's customarily written. Okay? Now then the last part, negative 6 and the negative 8 make negative 14, which that's your answer. It just says simplify. It didn't say factor, right? I'm done. Simplify means combine like terms. Moving right along. Number 2. Is it easy so far?
Of course.
Of course. All right, then. Give that one a shot. That's just the distributive property, correct? You're going to take the 5x and multiply it by both, which gives you 5 and 3 make 15, x to the 4th and x make x to the 5th. And then 5 times 2 is negative 10, x to the 4th. Number 3, 2x squared, 7x squared minus 4x plus 6. This is a monomial times a trinomial. Again, you take the 2 and you use it with all 3 terms. 2 and 7 are going to give us 14. X squared and x squared make x to the 4th. Now go to the next term. 2 and negative 4 make negative 8. X squared and x are x cubed. Last term, 2 and 6 make 12. So 12x squared. Before it gets a star. It's because of the A and B. You look at all the ones we've done before, we've just had one variable. So I'm going to multiply an A and B times an A. My opinion on this one is if you're struggling a little bit, watch this problem really close. It's the one that gets the star. Walk with me on it if you're struggling it. Okay, right here, I want AB cubed times A squared. So how many A's do I have in this situation? Because I'm multiplying, right? So we add exponents. How many A's? 3. And how many B's? 3. Now that's taken care of. Go to the next one. Let's start with the coefficients. A 2 and nothing here, so it's just 2. Now look at the A's. How many A's are there? An A times an A is A squared. Good. And then B cubed and another B make B to the... Excellent. The last stop is the easiest. just negative 3 and then attach the AB cubed. I ran out of room. That says negative 3 AB cubed. Sorry. Number 5. All right, every math teacher in America, we pray that you get this one right. What do you think? All right, everybody looks at it and just quickly thinks, oh, that's x squared plus 64.
No.
It's not. I know, right? It isn't, because this doesn't say, this is not 8x squared. That is 64x squared. Well, how could both, that can't be the same, right? So you have to actually, this is x plus 8. This is a binomial squared. So you have to FOIL. This is x plus 8 times x plus 8. You know what that means? So if you just write 8x squared and 64, wrong. Okay? You have to FOIL it. So x times x gives you x squared. X times 8 is 8x. Now you go the other way. 8x and 64. There's your 64. Those of you that have done any number sense or remember factoring in algebra, you can do this in your head. X squared, and you multiply these together, which is 8x, and double it. And there it is, 16x. And then 8 squared is 64. I'll show you that trick later. You just square this one, multiply them together, double it, and square the last. That's the fastest way. X squared plus 16x plus 64 is the answer. Now that I did that one, you try one on your own. 1/4 minus y squared. Remember what it means. Did it all cancel? No, I'm just kidding. I was just seeing you fell away. No, it does not cancel. I'm only kidding. Ready? 1/4 minus y times 1/4 plus y. 1/4 times 1/4 is your 1/16. Then you're at 1/4 y. Now go the other way. Oh, this is the minus. Go this direction. So another negative 1/4 y plus y squared. 1/16 on its own. What's a negative and a negative? If you have 2 quarters, you owe a quarter, and another quarter, you owe a half. So minus 1/2 y plus y squared. And usually the answer will be written that way because it was given to you that way. If you flip it and write it the other direction, it's fine. Number 7. We have 2 more. Okay, 1 and 9. X to the 5th plus xy squared times x squared plus y squared. FOIL, correct? Here we go, dive in. X to the 5th times x squared is how much? X to the 7th, right? I know, be careful. You add them. X to the 5th times y squared to go the other direction. This one's an x and an x squared, which is 3 x's and 2 y's. Lastly, 1x and 4 y's. Binomial and a trinomial. They're getting messier. Wait till number 9. I tried to skip number 9 in one of my other periods, but then when they got to their homework, they didn't know what to do. So we got to do all 9. Sorry. All right, let's try. Here we go. 3x to the 4th plus 15x cubed minus 21x. Go the other direction. Negative 4x cubed minus 20x squared plus 28. Now I'll combine lectures. Highest power first, 3x to the 4th. Gone. What am I going to put together now? The cubes. Excellent. Put these together, which is 11x cubed. Gone. What's next? Squares. Sometimes you will be able to add it, sometimes you won't. It just depends on the problem. Now put in your x. This is called descending powers of x. That's what we've got going on here. Okay? And then your answer will look like everybody else's, right? You're not searching for each sign. Last problem. This is a trinomial times a trinomial. Okay, watch, please. Yeah, the problem with this one is there's 3. So when you take the 2x, you go to all 3. What's my next step? The negative 3x to all 3. But I have one last step. What's got to come next? There you go. You got it. That's it. It's not hard at all. Distribute.
So that's the length of superpowers.
Oh my gosh. Guys. If you'd like to check the answer, here it is. Now, I'll foil it for you as well. That's the answer. my work at the top, and then the final answer is boxed. All right, you're all done, and you may start your assignment.